Hello everyone, so welcome to this video, and in this video we're going to solve now one-step inequalities, which is in first degree. So let's start. Okay, in solving now linear inequalities in first degree, it's either we go with add or subtract when it comes to one step, or multiply or divide. However, there is a catch when we multiply or divide an inequalities. We flip the inequalities whenever we multiply or divide it with the negative value. So the logic is still the same. When you, whatever you do at the left side, you do that at the right side. Okay? So let's have some examples. Solve for the solution of the inequality. So x minus 3 is greater than or equal to 5. Now, let's have this one. So let's have now our solution. Copying now the original inequality, x minus 3 is greater than or equal to 5. Now, what are we going to do? We add 3 both sides. So x minus 3 plus 3 is greater than or equal to 5 plus 3. Now, we have now x is greater than or equal to 8. So that will be our solution. X is greater than or equal to 8. So when you have that, it's 8 and above. So let's have now a solution. So on the checking, we test now x is greater than or equal to 8. So we want to use now x equal to 8. So we substitute now that. So 8 minus 3 is greater than or equal to 5. So 8 minus 3 is greater than or equal to 5. So 5 is greater than or equal to 5, which is correct. So we are now sure that our answer is x is greater than or equal to 8. Now, let's have now another example. So for the solution of the inequality, x plus 2 is less than 5. Now, let's have now the solution. So x plus 2 is less than 5, copying the inequality. So subtracting both sides 2. So we have now x plus 2 minus 2 is less than 5 minus 2. So the logic is still the same. Whatever you do at the left side, you do that at the right-hand side. So we have now x is less than 3. Now let's do the checking of testing x is less than 3. So we want to use now 2 because 2 is the first integer less than 3. So again, the inequality is x plus 2 is less than 4. Substituting now the value, 2 plus 2 is less than 5. So 4 is less than 5. So we can now say that our answer x less than 3 is correct. Okay, this is now another example. Solve for the solution of the inequality 5x greater than negative 15. Now, solution, so we have now 5x greater than negative 15. We divide both sides by 5 so that we have now the value of x. So 5x divided by 5 is greater than negative 15 divided by 5. So x is greater than negative 3. Now, let's do now the checking. If x is greater than negative 3, the first integer that we can use is x is greater than negative 2 because negative 2 is greater than negative 3. So using now the inequality 5x is greater than negative 15, substituting now the value, 5 times negative 2 is greater than negative 15. So we have now negative 10 is greater than negative 15. So we can now sure it, now at this point, we are now sure that x is greater than negative 3 is the answer in our inequality. Okay, let's have this last example. Negative 3x is greater than 21. Let's have now our solution. So negative 3x is greater than 21. What are we going to do is divide both hand side by negative 3. So negative 3x divided by negative 3 and 21 divided by negative 3. So the answer is x is less than negative 7. So as you can see, there is a flip in the inequality symbol from is greater than to is less than. Because the rule is that whenever we divide or multiply the inequality by a negative, the inequality symbol would flip. Okay, now let's do now the checking to verify if our answer x is less than negative 7 is correct. The first integer that is less than negative 7 is negative 8. To make it easier, so we have now negative 3x is greater than 21. Now, negative 3 times negative 8 is greater than 21. So we have now 24 is greater than 21. And we can now verify that x is less than negative 7 would be our answer for this inequality. I hope you learned something with one-step inequalities and you learned something with this one. Thank you for watching and have a great day, everyone. Thank you.